students, in our previous lecture I have explained how to use linear programming problem for solving problems related to finance with the help of solver. In this lecture I am going to explain how to use linear programming problem for solving problems related to operations. Like one of the very known, very reputed example is production scheduling. The reference for this problem is from the book Anderson et al. So, first we will see what is production scheduling. Okay. So, one of the most important application of linear programming deals with multi-period planning such as production scheduling. The solution to a production scheduling problem enables the manager to establish an efficient low cost production schedule. Okay. So, the objective of any scheduling problem is we have to give a schedule that will minimize low cost production schedule for one or more products over several time periods. It may be months or weeks. Essentially, a production scheduling problem can be viewed as a product mix problem for each of several periods in future. This is similar to our product mix problem. What is a product mix problem? That there are different products, say X1, say X2, so X3. How many quantities in each product X1 and X2, X3 has to be manufactured? This scheduling also similar to that problem. The manager must determine the production levels that will allow the company to meet product demand requirements given the limitation on production capacity, capacity of the plant, storage space, while minimizing the total production cost. So, what is the objective of a production scheduling problem? We have to prepare a schedule that will minimize our production cost. One advantage of using linear programming for production scheduling problem is that they recur. Because the scheduling is a very operational problem, every month or every year that scheduling need to be done. So, once a mathematical model or an Excel model is prepared, that can be reused. That is the advantage of using Excel. A production schedule must be established for a current month, then again for the next month, for the month after that, and so on. When looking at the problem each month, although demand for the product has changed, the remaining factors like production times, production capacities, storage space limitations, and so on are roughly the same. Only the demand will be changed. The same model can be reused for different periods. Thus, the production manager is basically resolving the same problem handled in previous month, and a general linear programming model of production scheduling procedure may be applied frequently. So, once if you have a spreadsheet modeling for the scheduling, that model can be used for coming months. That is the advantage. Once the model has been formulated, the manager can simply supply the data, for example, demand, capacities, and so on for the given production period, and use the linear programming model repeatedly to develop the production schedule. We will take one example. I will explain how to formulate a production scheduling problem, then the solve with the help of solver, then we will interpret the result. A company which produces two different electronic components for a major airplane engine manufacturer. The airplane engine manufacturer notify the company sales office each quarter of its monthly requirement for components for each of the next 3 months. So, the company is receiving the order for next 3 months. The order is shown in the next slide. For example, there are two products there, 322A, 802B. So, April month, May month, June month. This is the demand that we need to fulfill. So, for this we have to give a production schedule. What is the meaning of here production schedule? How many products, for example, here how many products I am using X11, that is for product, this first one represents the product type, the second one represents the month. Say here it is X12, product 1, month 2. If I write X13, product 1, month 3. Similarly, for product 2, X21, X22, X23. Okay. So, we have to suggest in each month for each product how many units has to be produced. That is an objective of our this production scheduling problem. When we go for a production scheduling, there are three elements of cost is there. One is actual production cost, then inventory holding cost. Sometime we may produce more than the demand, that has to be stored for the next year demand, next period demand, that is inventory holding cost. Then the other is the change in production level cost. Suppose this an example, we can say the setup cost. So, currently my company say suppose I am manufacturing with 5,000 units. So, my demand the next month is say 6,000 units. Now, I have to increase my capacity 5,000 to 6,000. So, that cost is called setup cost or change in production level cost. It is not only increasing, sometimes it may be 4,000. Now, we have to decrease my production level. So, that cost is change in production level cost. So, here the problem is formulate a linear programming model of the production and inventory process to minimize the total cost. As I discussed in the previous slides, this is my decision variables X11, X12, X13 for product 1. For product 2, X21. So, this first number represents the product, second number for example 1, 2, 3, that number represents the month. So, if it is 1, it is a month April, 2 it is May, 3 it is June. So, now this is the decision variables. Let XIM denote the production volume in units for product I and month M. Here I represents product, say is 1, 2 because we are using 2 products. M is 1, 2, 3 because we have 3 periods. So, if I equal to 1 refers to the component 322A, if I equal to 2 refers to the component 802B. M1 refers April, M2 refers May, M3 refers June. There is an advantage of using double script because we can represent both product and the month. So, the purpose of double subscript is to provide a more descriptive notation. We could simply use X6, for example, you can call it this is X1, X2, X3, X4, X5, X6. We can use product 2, the June month requirement is X6. Okay. But if you provide this X23 instead of X6, when you provide X23 is more descriptive and identifying directly the product and month represented by the variable. That is why we should go for double subscript, that will provide more clarity on the decision variables. Now, we will formulate our objective function. As I discussed earlier, that objective function has 3 components, one is the production cost, inventory cost and setup cost. Now, we will go for total production cost part of the objective function. If component 322A cost $20 per unit produced and component 802B cost $10 per unit produced, the total production cost part of our objective function is 20 X11, for example, say this is 20, this is 10. See what you say, this is our production cost. So, what you have to do? You have to multiply by corresponding to the decision variables. So, here it is X11, X12, x13, x21, x22, x23. So, it will become 20 x11, 20 x12, 20 x13 for product 1. For product B, 10 x21, 10 x22 and 10 x23. The next component is inventory holding cost. So, for inventory holding cost also we are going to use this decision variable S. Say when I say S11 for example, this is product 1, product 2, this is month 1, month 2, month 3, but here S represents the inventory cost. So, if I use SIM denote the inventory level for production I at the end of month M. On a monthly basis, inventory holding costs are 1.5 percentage of the total production, total product. For example, 1.5 percentage 0.015, the product cost for product 1 is 20. So, there is a $0.30 per unit for component A, and if you multiply it by if you multiply 0.015 multiplied by 10, okay, for the second product. So, for the second product inventory holding cost is 0.15 per unit per component. Here the common assumption made in using this LP approach to production scheduling is that the monthly ending inventory are an acceptable approximation to the average inventory level throughout the month. So, generally how it is done, generally inventory, suppose inventory like this, assume that I have ordered 500 units. So, this is week 1, week 2, week 3. So, my inventory level will keep on decrease, okay. For example, it is 0. Generally we will do the average of this, but in this problem, so the average inventory is equivalent to that month ending inventory, that is the meaning. So, monthly ending inventory are an acceptable approximation to the average inventory level. That is what the meaning of this sentence. So, now we will go for the inventory holding cost. We know that for the first product inventory holding cost is 0.15. So, when you multiply it by corresponding decision variables for inventory, so 0.30 S11, 0.30 S12, 0.30 S13 for the product 1. For the product 2, 0.15 S21, 0.15 S22, 0.15 S23 for product 2. Next we will go for the setup cost. The cost of fluctuation in production level from month to month. So, we are going to use this notation. IM represents increase in the production level necessary during the month. Quantity. DM represents decrease in production level necessary during month M. We discuss about the cost fluctuations. After estimating the effect of employees layoff, turnovers, reassignment, training cost and other costs associated with fluctuating production levels, company estimates that the cost associated with increasing the production level for any month is $0.5 per unit increase. A similar cost associated with decrease in production level for any month is $0.20 per unit. So, we write the third portion of our objective function. Okay. So, we have 3 months, 3 months there is a possibility of increasing, there is a possibility of decreasing also. For increasing cost is 0.501, month 1, month 2, month 3. The same month there is a possibility of decreasing D1, D2, D3, but the increment and decrement will not take place simultaneously. The next slide I will explain. Note that the cost associated with the changes in production level is a function of change in total number of units produced in month M compared to the total number of units produced in month M minus 1. Okay. Suppose we say 1, 2, 3, we start from 0 months there. Suppose here this is M minus 1, this is say M. So, the difference in units, that is called your change in production level. In other production scheduling applications, fluctuation in production level might be measured in terms of machine hours or labor hours required rather than in terms of total number of units produced. Now, we are considering the change in production level is only in terms of number. Okay. It is not necessary, sometime we can consider change in machine hours, change in labor hours. Now, I am going to write the complete objective function. Okay. So, this is my this portion x 1 up to this is my production cost. Yes, this is up to this is my inventory cost, this up to this is my setup cost. Now, we will go for writing the constraint. So, here we will write constraint for first we have to fulfill the demand. So, here see the extreme right this one. So, this month demand, okay, we have to fulfill this demand. For that ending inventory from previous month. Okay. So, current month production it has to be added. So, your ending inventory plus current production directly will satisfy your monthly demand. If any unused unit, that will be stored, that is I have brought on the left hand side, that will stored as the inventory for this month. Okay. So, the general equation is ending inventory this month plus current production, that will satisfy that month obligations. After satisfying that month demand, if any excess unit is there, that will be stored as a, actually it should be this side. So, I brought it on left hand side. So, it will be stored as a inventory in that month. So, that can be used for the next month, that will be carried for the next month. Okay. Now, we will write for constraint for month April. Okay. So, what will happen in the April month, there may be some initial inventory, the month of March. Okay. Suppose that the inventory at the beginning of 3-month scheduling period were 500 units for product A, 200 units for product B. So, the demand for both products in the first month is 1000. Okay. So, the constraint for meeting the demand in the first month become, we use the same idea. So, the beginning inventory, okay, then that month production for product 1, that will be fulfilling the 1000. If any extra is there, that will be stored for the inventory. This is for product 1. For product 2, we have beginning inventory 200 units plus April month production, that will used for fulfilling that month requirement. If any extra unit, that will be stored. So, I have brought on left hand side as a inventory. After simplifying, this is the final equations. Like this, we are going to write for May month and June month. Say for month of May, see this S11, right, this we have carried from, this is 1, 2, 3, this is carried from April. This is my beginning inventory plus second month production, that these when I add this should fulfill my 3000 units. Yes, after fulfilling any additional unit is there, that will be stored as inventory S12. Okay. So, product 1. So, this is for product 2. The third month, you see this S12 will be my beginning inventory from second period. Then that month production, third month production, This will help you to fulfill 5000. Any additional unit, that will be added as a S13. Similarly, for the product 2 also. Okay. Now, there may be a requirement for the company, this much ending inventory has to be maintained. If the company specify a minimum inventory level at the end of the 3-month period, say at least 400 units for component A. So, S13 should be greater than or equal to 400 and at least 200 units of component B. So, we can add this constraint S23, because this is in the 3rd period the inventory available. Now, we will go for our capacity constraints, capacity for machine, labor and storage capacities. So, we have machine capacity, this is resources available 400 hours in the April month, 500 hours May and June. Similarly, for labor hours, similarly for storage capacity, we have 2 products. So, this says how much hours per unit is consumed by product A in the machine, say 0.10, this one 0.02, this many hours per unit is consumed by product 2. This is for machine, labor and storage. So, we have to write constraint for machine hours, we have to write constraint for labor hours, we should write a constraint for storage capacity. Always this should not exceed, so it should be less than or equal to type. So, we will be writing that constraint. So, I have brought this labor hours per unit and the total available resources. So, what will happen? We know that this will be consuming 0.10 x11, okay, for product 1, then this will be 0.08 x21. Okay. So, that should not exceed over 400, this 400 in the month 1, that is why we wrote this 400. Similarly, the May month 500, June month 600, then we will go to labor capacity. So, this is x1. Okay. Now, we will write the constraint for the labor capacity. So, see for product 1 it consumes 0.05 hours per unit. Okay. So, 0.05 x11 for product 1, for product 2 0.07 x21. So, that should not exceed your 300 month of April, then May and June. Now, we will go for writing constraint for storage. So, the product A occupies 2 square feet. So, 2 S11, because you see that this is our inventory variable, that will be stored 2 S11, 3 S21, that should not exceed 10,000 in the month of April. Similarly, that should not exceed 10,000 May for the month of May, then 10,000 for the month of June. Okay. Now, we will write the constraint for our setup cost. For example, if you consider March and April, see we have problem only from April onwards, April, May, June, but I am going to consider what is the setup cost between March and April. Suppose that the production level for March, that is a month before the start of the current production scheduling period, had been 1500 units of component, okay, and component A, and 1000 units of component B. Okay. So, the total production level is 2500 units, 1500 plus 1000, 2500 units. Okay. We can find the amount of change in production for April, okay, from the following relationship. The same thing, first one is April month production and the previous month production, say the previous month production, that difference is change. Using this April production variables x11 and x21 and the March production of 2500 units, because this is given for the March. So, April production is this one x11, x21 and the March production is 2500, this difference is change. So, this change I am writing in two variable I1 minus D1, I1 is increment minus D1 is decrement. Instead of using two variable, we can use only one variable, but there is an advantage, I will explain. We cannot have an increase in production and decrease in production during the same 1 month period. That is, it can be either I1 or D1, okay. It cannot be both. Suppose if the April requires 3000 units, okay. See, the previous month production is 2500. So, 2500, the difference now we are see the March month production is 2500. Suppose the April production is 3000. Okay. This difference is now it is increasing. So, the value of I1 will be positive. So, D1 will be 0. Suppose the April requirement is 2200. In the March itself already we have 2500. Now we requirement is only 2000. Now it is decreasing. Now the value of I1 will be 0, but D1 decrement has to be done, okay, because the next month it is only 2200. This approach of denoting the change in production level as the difference between two non-negative variables I1 D1 permits both positive and negative changes in the total production level. That is the advantage. If a single variable, say something Cm, had been used to represent the change in production level, only positive changes would be possible because of the non-negativity requirement. The negative changes cannot be represented. That is why the change is represented by two variable I1 D1. Advantage is we can represent positive increment value and decrement value. Already I have explained in the month of April. Now we will write in the month, suppose if you are jumping from if you are producing from April to May, okay. So we have to go for May month production, that is X12, X22 minus April month. April month is X11 plus X21, okay. That difference is I2 minus D2. So if you want to find out the variable between May and June, so June month production X13 plus X23 minus April month production X12 plus X22, that will give you the I3 equal to D3. Now we will bring all our complete problem. This is minimization problem because we are minimizing the cost. I have written my objective function, then I have brought the demand constraint for each month, then I brought the ending inventory constraint, then I brought the capacity constraint, machine capacity, labor capacity. The production scheduling problem I have solved with the help of solver. I brought the output of the solver. How to read this output? You see there are product 1, month 1, this one. This is product type 1, month 2, month 3, this is the month 3, this is a production schedule. Product 2, month 1, month 2, month 3. This is inventory. How much inventory? This is our inventory cost. This is our increment or decrement cost. So, this is we have to minimize the cost. So, the value of objective function is $2,25,295. Now, I will explain with the help of solver how I got this result. Now, I have brought this Excel sheet, already I have solved it. So, I am going to change these values here, so that I will solve this problem here itself, so that you will have a better understanding. Just I am okay. So, this is decision variable cells, this is a coefficient of objective function, these are the various constraint. So, go to data, so go to solver. Okay. So, this is minimization type. So, when you solve it, now when I look at the answer report, I am able to see the value of objective function 2,25,295. Here I have the values, here I have the values for all the decision variables. So, x11 500, x12 3,200, x13 5,200 and so on. Okay. So, this is the our production schedule. Now, I have brought the production schedule in the form of table. So, this table gives the, for example, say the product A in the month of April, this is a production schedule. Month of May 3,200, month of June 5,200. The most important thing is when you are providing the output, you should give this output such a way that the manager able to easily understand. Instead of simply showing the Excel, you have to brought in a form so that the manager can easily interpret, that is more important. So, the total cost for this production schedule is 2,25,295, otherwise you can say $225,295. So, in this lecture I have explained the application of linear programming problem in operations area. The problem which I have taken is production scheduling. So, we have taken a problem and formulated the problem, and we have given a production schedule for the company, so that it will minimize the total production scheduling cost. Thank you very much.